Welcome back, Matlow. Yesterday, I had given you an insight about what is the basic behind calculus. So this was one of our functions one of my student was interested in. So like x square plus 2x plus 4, it's a quadratic since you all learned in 10th standard. It's in a parabolic shape, which I can show you. I was telling you yesterday, like what is a curve. So this is again a curve, a parabolic curve. But if you can notice, everyone from this kind of a perception, they are going to claim, yes, it's a curve. But I was telling you when you zoom in. So now I'm showing you that also. When I keep zooming in closer and closer, right? So everyone will be able to see only kind of lines, small lines. No one is able to be say that this is a curve with this close magnification. Okay. So this is what I was saying yesterday. Curves are also made of infinitely small number of lines. So now let's take some point, meaning uh, I'll take some integer point that'll be easy. So this is the value of the function at x equal to 0. So I was also telling you what function is y equal to f of x. Here my function is x square plus 2x plus 4. Okay. So at x equal to 0, you can notice the value of the function is 4. That means at x equal to 0, when you substitute x value here, 0 square plus 2 into 0 plus 4, I'm getting 4 as the answer. That's the value of y. As a point, it's plotted as 0, comma 4. So now this is my value of the function at some point. I can choose any point I want. This is at some point. Now, if I take a very close point, meaning like say I'm going to take x equal to 0.1. Okay, then the value of the function is going to be 0.1 square plus 2 times 0.1 plus 4. That's going to be my new y value. Okay, I'll also show you where that is by drawing a line here. X equal to 0.1. So I've kept a line very close to it. As you can see, I'm also going to zoom and show that to you. Right? You can see that I'm just zooming in this small gap between this x equal to 0. I'll also show you that x equal 0 part. Between x equal 0 as a green line and x equal to 0.1 as a blue line, you can see in that small gap, this curve kind of looks like a straight line only. So this value of 0.1 square, which will be 0.1 by 10 whole square, right? 1 by 100, 0.01 plus 0.2 plus 4. So you get to see the value is coming around 4.21. So from value of y equal to 4 to y equal to 4.21. So you can see there is a change which happened in the value of y. Y has moved from 4 to 4.21 and x has moved from 0 to 0.1. So this is what I was claiming as change in y and change in x. So our slope for this particular line, if you see that small, infinitely small line, the slope is like we define what a slope. Slope is being defined as change in y by change in x. So which is like from 4 to 4.21, the change is 0.21, 0 to 0.1, the change is 0.1. So it basically becomes like 21 by 10, which will become like 2.1. So slope is around 2.1. Now you can see at least significantly that these two lines are separated by a gap. But what calculus believes is if this gap is being continuously kept on reducing, then there won't be a straight line and all. There will be just a point very close. You will not be able to kind of see that gap, that kind of infinitely. So instead of x equals 0.1, think about if I go very closer like 0.01, x equal to 0.01, then you can see the lines are almost close. If I make it 0.001, 0.0000001, then the beauty is then we can just consider it as a point. So this was the basic thought process behind creation of calculus. This smallest, minute, infinitely small gap is going to be just considered as a point. So that's why we say slope at a point. That's why we are going to claim happily that is slope at a point itself. Because both the points are separated by an infinitely small gap. Okay. So through this only the differentiation idea also began. Differentiation creating like change in y by change in x, dy by dx. So here, so please follow this idea. So my y equal to f of x. Okay. So I am trying to find out the value of my function at some x value. Okay. My function's value at some x value. and my function's value at a little bit away from point with respect to x, little bit away. How much away? It's very, very minute change. Like that change is only h. That small change from x value is only x plus h at a newer point. I was giving you an example from 0 to 0.00001. So that kind of a. So this difference is going to give me my change in the function's value, function's output values divided by the change in the input value. The old input was x, the new input that you are giving is x plus h. So now you can understand this is how the idea got created. This is going to be equal to dy by dx. The slope at dy by dx is claiming at slope of the tangent at a point to the curve. But for that, h cannot take different values. Like it has to be very small value close to 0. This is where they introduce the word limit. LIM, in short, they write limit means value tending to, value being close to. So here we are claiming the value h is being very close to 0. So it means close to 0 means not equal to 0, close to 0, maybe 0.0001 or minus 0.001. That's what it means by. So if this word limit h tends to 0 is not there, then this has no meaning with respect to calculus. This would just mean change in y by change in x. It cannot refer to slope at the point. So here dy by dx is actually referring to slope at the point of the curve. If anyone is going to put this f of x plus h minus f of x by x plus h minus x without informing that h is a value very close to 0, then this would be a wrong definition to make. Hope you understood this in a shorter way. I again repeat the graph that I had drawn yesterday. So if this is your graph, if this is the x value I'm taking, and with the smallest, minutely smaller gap, and this is going to be the new value x plus h, there is a y value here that was created by when you substitute the input x plus h. There is a y value here which is created when you substitute the input as x. So there is a small gap in the outputs and there's a small difference in the inputs. So that's what dy by dx. So calculus believes when you keep closing on this gap, this small gap as infinitely small, then it would become like a point itself. Then you can call it as tangent at the point. Hope you are now understanding very well the idea of what is slope, where did this calculus come in and all. So we'll see more interesting content about this in forthcoming classes. Thank you.